Welcome everyone. Today we have our another new episode, and this episode based on manufacturing and 3D printed printing. And I believe that this is very important for cutting edge technology. Previously we do these shows, and Professor Rob actually gave us some guidelines on 3D printed, and it was so popular in Asia Pacific. And I'm sure from today's discussions, our audience will get a really guidelines from our world famous speaker, Professor David Smith, Mr. James Ed, Mr. Dan, Professor Rob, and Professor Edward. Thank you for joining today's sessions. And today we have a good news that already we published our 25 members, those who are our board of advisor today, all of our members, actually our board of advisors, we have 14 ambassadors from 14 different countries. They are working with our main committees, and I'm always ready to serve for World Talent Economy Forums and the global community. So we have 40 members in our board, and I believe that if the 40 members board, we work together because they are so popular, they are listened, they are popular with their work. Hopefully we can solve many problems. So I want to start from Professor David Smith. How do you want to analyze today's topic, especially manufacturing and 3D printing?
Well, Sharif, thank you so much. 3D printing for many years was a technology that was not ready for prime time yet and just down the road. But we've really begun to see 3D printing coming into its prime in a lot of different areas. One of the important things about 3D printing is what 3D printing is called additive printing. It builds things up by depositing layers together to build a whole. Where there's also a type of manufacturing called substitutive, where it actually takes stuff away to build it. So 3D printing, where it can be used as an additive approach, is a tremendous advantage, and we're seeing it used widely. 3D printing is done on the International Space Station. 3D printing is used a lot of different places to begin things. One of the great applications of 3D printing I see is in research and development. It's dramatically changed the amount of time it takes to do a prototype. And you can go through rapid ones. And because it's running off of a software model, you can make changes very rapidly compared to how you've had to do that in traditional manufacturing. Um, One of the things that you see really talking about there is that the use of materials have dramatically expanded that you can use with 3D printing. And it is one of the things that will really reach out and change how we're doing. But one of the stories I want to tell to kind of get into this with you is I'm on the investment committee and a mentor at the International Accelerator, which is a group headquartered in Austin. And it was just so funny when I saw your topic pop up on this yesterday. Uh, Actually, just yesterday, we admitted from India a 3D printing company into the International Accelerator that does metal 3D printing. And their prime target is, for example, the aerospace industry, where the aerospace industry is now beginning to 3D print parts that can be used in different areas. And one of them is kind of interesting is one of the big challenges, and I've been flying a lot, and almost all of my flights have been delayed because of mechanical reasons, is access to parts and parts inventories. And that has been something that's been really challenging, and that's the marketplace they're in. But the last point on this introduction of it is COVID actually has been a real interesting enabler uh, in 3D printing. One of the things we learned in 3D printing in COVID is we did not have local manufacturing capabilities in a lot of the world. And so we've seen 3D printing pop up many places around the world uh, to meet that need. And really during COVID, the additional growth of 3D printing was almost $40 billion that can be attributed to the growth of 3D manufacturing as a result of COVID. So real interesting opportunities, some neat capabilities, and is one that we're now in the big growth period of that going forward.
Thank you. Thank you, Mr. Jamsid.
Thank you, Sharif. And if I can cede some of my time back to Professor David or Professor Rob, I'm a binary guy at best, zeros and ones, I understand. And I understand if I fit a piece of paper into my printer that we can print ink onto that paper. But I don't understand how we can print metal. And maybe I'll just take a moment to let someone explain to me, how does that actually work? Anyone?
James, do you know how to solder material, right?
Yes.
Same process.
Okay.
Okay, now I can follow that. But what I'm trying to get across is that my mind is boggled by this. And the idea that we can print materials, we can assemble them. Now, I'll talk a little bit about what that means to me. And what that means to me is that I can visualize something, create it on my computer, and then hold it in my hand. And I don't believe in miracles, but I think that's marvelous. And it's a marvel of technology, because what I can do now is see it and alter it in my hand. And then I can change it back on a computer. And so all of this is increasing my ability to create. And what we're trying to do is to enable the creation of new ideas and put them into, create them into reality. So it comes from your head, and then you can hold it in your hand. So what this means to me in terms of research and development is hard for me to get my hands around, but I know it's big. And so I think the resources that we put into expanding this capability are essential. And I'm actually quite happy to hear that there are companies in India that are being accepted into other organizations that are focused on this and delivering it. And the idea of using this for aerospace is just another marvelous application of this new capability, which I am still struggling. Even though I know what a sorter is, I just think that the assembly of raw materials, and now we're talking about, like, I was thinking, okay, plastic, but now we're talking metals. So this is just expanding my own awareness of what is possible. And so yes, so we're just at the dawn of this, and who knows what we're going to accomplish in the future. And I try to hold back on being wildly optimistic anymore, because that's led to disappointment. But I'm guardedly optimistic that this is a brand new frontier. Thank you, Sharif.
Thank you, Mr. Dan.
Mute.
There we go. That's on mute. Okay. Yeah, I know this is an area that is just expanding by leaps and bounds, and I put in the chat, for example, if people want to check out a company called RelativitySpace.com. They actually 3D print rockets, rocket engines, and rockets. They have the world's largest 3D metal printer, and they claim they can go from raw materials to a flying reusable vehicle in 60 days. So I mean, this could be Elon Musk might need to invest in some 3D printer technology. But they've been doing this at very expensive small scale levels for a while. I know with when they manufacture computer chips, they use something called an ion implanter, and it basically fires atoms of metal, one ion at a time onto chip boards, silicon wafers to dope them usually, but there's all kinds of additive manufacturing. There's subtractive manufacturing too. It all falls under the category of what you could call rapid prototyping, or even desktop assembly. Or there's a great book out from the Center for a Stateless Society called "The Homebrew Industrial Revolution," which even though it was written in 2006, it's still completely relevant. And it predicts that when people have the ability to do a wide range of production and builds under their own home roof, think of all the freedom that gives you. Think of all the disruption that causes to inordinately long supply chains. It's kind of interesting. We say, oh, China is such a bad criminal environmentally, but that's because China is producing all the little gadgets and parts we need. We've outsourced our pollution overseas to China, and then we blame them for this. So that's really not fair. We need to bring all these externalities back home and do them in a clean way with massively distributed home-based things like 3D printers and the various other machines that can be used to in kind of a civilization starter kit that open source ecology advocates with Marcin. So those are just a few opening thoughts, and thanks for the opportunity.
Thank you, Professor Rob.
Well, as others have pointed out, 3D printing is referred to under a general category of additive manufacturing. Currently, it's predominantly used in prototyping and in short-run parts. The automotive industry has been the industry that's been the most excited about this, particularly with regard to support for the aftermarket and support for cars that are aging out that may still be covered by laws that require support for up to 10 to 20 years. So that's played very well because it's very expensive to do short-run parts on traditional methods using compression plastics. Some of the others is the setup cost and building the molds. You never recover it because the number of parts you build is just too short, and the price is too low to make that work. And 3D printing has stepped in there very nicely and provided a way to build these parts and keep car hobbyists, older vehicles, delivery trucks in particular have a half-life. We probably measure in half centuries now. So that's where it's been most useful. Predominantly plastics and polymers. Some of the more advanced 3D printers now can produce polymers that have capabilities similar to metals, though not identical. They still have relatively low melting rates because you're predominantly using heat in the different methodologies to build the underlying part. The 3D printer I'm most familiar with is the Hewlett-Packard 3D printer, which doesn't use strings of plastic, but prints in layers and builds the part up. And they've been able to showcase that they're able to build actual production parts and just prototypes that way. And we're one of the first to do that. Most recently, they've moved into colors and into metals. In metals, metal sintering was the one that I was most familiar with, a very expensive process, very high quality. There are two other methods of using metals, 3D printing, but they're quite a bit more expensive than using polymers at this moment, but far less expensive than using computer-controlled milling machines, which is the subtractive method of using of computers and building parts. Also very high tolerance, though. As we move forward, what we're working on now is mixed material 3D printing. I mean, the goal at the end is, if you're an old fan of Star Trek, is to build something like Replicator, where you put a set of plans in and something finished comes out. We're a ways away from that. The methods we were using for either metals or polymers, because the distinct difference between them makes it very hard to blend the two. But that's what we're working. And there's been good progress in being able to try to build electronics into the process, though we can't yet use 3D printers to print electronics. There's the belief you could have preset components and then print around those components to build more complex things going forward. Where 3D printing is going to probably play a huge role and is playing a huge role is in space. As you talk about the Mars expedition, they're most likely going to have to create much of what it is they use. They're not going to be able to wait for Amazon to roll a truck and drop something off. They're going to have to build it there from raw materials. And 3D printing isn't just being used in physical objects like we're used to. It's also being explored in foods, and they're making some progress with regard to that as we move to artificial meats and the rest. It is believed that eventually we'll use some type of 3D printing capability to produce it in volume. And as we move to machines that can print food, obviously we're using something like 3D printing to do that, but that's still well off into the future, and a few FDA approvals away from where we currently are. That's kind of it for me on 3D printing right now.
Thank you. Professor Edward.
Yeah. Well, these have all been very insightful observations. I'll add a few items. Rob and the others are right that the future is really going to depend on to what extent, first of all, you can use more and more materials. Metals, of course, we've talked about polymers, plastics, of course, first, I think at least a decade or so, you could go into a computer store here in the United States and get a 3D printer that can print little toys. That's very nice, but that's not industrial level. And to blend the materials, because we have seen, for example, 3D printed houses. There's a big machine you might have seen to do that. We've talked about the 3D printed rocket engine, and one of the things I'll also highlight is 3D printed medical implants. Somebody loses a jaw or something like that in an accident or whatever. We now have the capacity to 3D print exactly what is going to fit in you. So it's not just to tailor make implants and other things too. So I highlight the medical area where really precision is important, and this is one of the things that's coming up. But I want to mention two other points. One is that, of course, a lot of what we're talking about are prototypes, customizable items, whether it's a particular engine design or whatever. And that's going to be a big area, and I see that as an expanding area. I've mentioned, for example, that when we get into 3D printed clothing, I can basically say, I want a shirt like this, but I want it to have this kind of button and this kind of design and this kind of color and all, and I push a button, and then I pick it up at my local laundry, when I go to pick up my clothes or something. So you're going to have this capacity for individuals to really tailor what they want. The other thing, though, and this gets into your bigger question about mass production. In the past, of course, mass production, and Henry Ford being the kind of father of this process, basically you have an assembly line process where you have the chassis of the cars here, and it goes down the assembly line. Then you stick the axles on, and then you go down and you stick something else on, and you kind of do that. Bang, 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 bang. And that's what gets the cost low. So one of the big questions in the future is going to be the cost. To what extent is 3D printing going to be involved in mass production? Is it going to be a mix or what? I mean, in a sense, you can look at it as how do we blend the mass production process with the new technology? How do we integrate it? Because cost is always important. One of the things we always warn about in these discussions is we have a new technology, and so we say this is really great. We have a hammer, so everything looks like a nail, but in fact, technology is simply one tool out of many, and so you have to ask where it applies. And so I think that that's going to be a big thing moving ahead, is to what extent can 3D printing economically support the production process. And by the way, in automobiles, I think Rob mentioned this, I've seen that for some years now, but that's going to be the big question, is not only expanded use of materials, but what is the cost? Can you produce whatever it is on a mass scale, or is it going to be some in-between customized process? By the way, there's a book called A Distant Shore that just came out by a science fiction writer about a trip to Mars. And it's a very good book. I highly recommend it. And central, and the guy's actually I think he's an astrophysicist. And one of the center points is the 3D printer in the spaceships going to Mars. The spaceships going to Mars, and so and he actually is pretty knowledgeable about this. So if you want a science fiction version of this, take a look at his book. So, oops, I think
Sharif may be frozen. I think Adam, you're up next.
I think yes, Adam, why don't you take over?
Unmute myself. Okay, thank
Yeah, good idea.
you. So,
Mr. Adam.
Oh, there he is.
thank you, Sharif. I remember during one of our discussions prior, I think it was on the subject of e-education.
Mr.
Adam,
Adam,
we can
can
barely
you?
hear you. You're really quiet.
Volume.
Oh, I'm right.
Rub your microphone in, and it's wandered across the room. Nope, you're still really light.
How about now?
Still light.
We barely hear you.
Oh,
Well,
No problem.
but
can you hear me now?
Yes.
Hi.
Yes.
Cool.
harsh.
I think something's wrong with my headphones. So I remember during one of our discussions prior, I think we were talking about e-education and e-learning within e-business, and I think it was that topic when we highlighted the anecdote about some higher up in a computing corporation. I think it was IBM, and said during one of the decades when computers filled entire rooms still, where this guy allegedly scoffed at the idea that one day some people, eventually most people, like I say, will have personalized computers in their homes, at least one in each household, one or more in the future. And of course, printers have already existed for some time already, but they are still mostly, I think, confined to specialist labs and workshops, industry, engineering, vehicle production, multinational corporations. So it feels to me that 3D printers aren't that deep in mainstream public consciousness just yet. And I would say most people have heard the term already, and it's just quite a self-explanatory name, but maybe most ordinary people would not be able to explain off the top of their heads exactly how they work or why they are better than past generation counterparts or ways of constructing. I don't think we have reached the point where 90% of ordinary people will be scrambling to get one each as the new must-have device that people queue up around corners at 5 a.m. for. I don't think we've reached the point where most normal people would consider having one yet, let alone queuing up for one, like how people do for iPhones and things. So it's mainly out of sight, out of mind for ordinary, non-specialist, non-professional people. But I think 3D printers will be eventually, just like PCs did, just like paper printers and copiers and fax machines did. And I think they are so useful that 3D printers will last longer in the market, especially when compared to some kinds of devices and media that came and went already, videotapes, cassettes, fax machines, which became obsolete quite quickly in the grand scheme of things regarding innovation. But I don't think 3D printers will fall to that kind of obsolescence so quickly. Well, certainly not for a long time, relatively, in my opinion. I also think that just like smartphones are no longer just telephones, they are also many things simultaneously, of course: cameras, dictaphones, video recorders, social media hubs, torches even. Like with laptops, gone are the days where desks are cluttered with documents everywhere, typewriters, pens, pencils, rulers. Since you can do all these tasks these items were used for on a laptop. Same with musicians. And some people are making whole albums on a computer or laptop, whereas before one would need a mixing desk, some synthesizers, keyboards, a microphone, effects pedals, and so on. So I think 3D printers will have similar characteristics where they will be multifaceted, multitasking, like a Swiss Army knife in regarding what it can make, thus saving space and saving complications and complexities and having to synchronize different things, and they won't have cables and pieces of paper everywhere. So thank you, Sharif.
Thank you. Mr. David Smith, as we are discussing on manufacturing and 3D printed, and this is new for us, and even the Asia Pacific actually manufacturing hub, but I am sure that they are doing a lot of research and developing different cutting edge college for doing research on 3D printed. So if you give us some idea that what area in manufacturing we can use this 3D printing technology, especially in the manufacturing industry?
The answer to your question is really, it's a very broad use of it. You know, you can use 3D printing in manufacturing to keep your traditional manufacturing environment working. It is a really simple one, because the many manufacturing processes break, and it takes inventorying things for parts. A lot of the manufacturing infrastructure is old, and some of the parts aren't available, and you can begin to 3D print some of those. But 3D printing as a manufacturing process has applicability in most domains. 3D printing is used in medicine, it's used in pharmaceutical, it's used in aerospace, it's used in automobile manufacturing, it's used building houses today, it's used in many manufacturing areas. And it's as we begin to be able to use more materials in 3D printing, the use is going to continue to grow. One of my favorite materials is 3D printing is really good with printing graphene and using that type of structure, which has an advantage being lightweight and high strength. And it can be used very easily in that area. But, you know, some of the interesting things to answer your question is in some of the manufacturing domains. In some ways, 3D printing can reduce cost in manufacturing. And as Rob said, it's really a question between the volume of what you're manufacturing. 3D printing in the past has been used quite a bit in low volume manufacturing, but we're beginning to see it be used in more high volume. And one of the reasons it's being used in high volume is the ability to make minute corrections in the manufacturing process is all under software. And so as you run a lot, you can enhance a lot as you're running it through the manufacturing process. 3D printing and manufacturing really reduces risk. You can go through multiple iterations before you have to commit to build a massive manufacturing facility. In some ways, it's faster to market. One of the tenets in manufacturing that I learned really well in the semiconductor industry is failure has a big cost when you're in a large manufacturing run. 3D manufacturing has the advantage that failure is cheaper in 3D printing than it is in traditional manufacturing processes. And there's many others, though. There's less storage, there's less waste. Usually, one of the areas being promoted heavily in the manufacturing journals and things right now is 3D printing is more environmental friendly. So it begins to do that. But to your question, most industries can use 3D printing today in some way to do manufacturing. And I think Sharif has locked up again.
Okay, I think I'm up
Thanks
next
to
time. Okay. You know, this has been fascinating to me. I really appreciate this discussion because I only had a little bit of interest in this subject until I've heard some of these ideas that have expanded my awareness, and I'm now really interested in the subject. And I want to say the reason that I wasn't so interested in it is, you know, we're talking a little bit about, you know, making an assembly line more efficient, which would make it a company more profitable. I have no interest in that, and I'm not a Marxist, but I am a post-capitalist. I'm a capitalist. I do think that we need to think about what is the quality of life, because if we displace the workers on the assembly line, that's great. Assembly line jobs aren't very humane. But what do we do with the people that we displace? What is the cost that we're doing? But what I'm seeing here that has a human impact, I don't know, I don't care if companies can be more profitable, but I do care if the quality of human life can be improved. And the idea that you can get your jaw destroyed in in an accident or whatever, and at the hospital, you can print a replacement in real time, not wait for it to just ship it out to somebody else to build it, to ship it back. And then that's an amazing, humane improvement in quality of life. And I'm also, that's just one example where this technology can be used to improve the quality of life in so many aspects that it's gone from a kind of off the radar idea to me to one that I'm going to pay significant more attention to. And the idea of sending a ship to Mars with a local printer so you can build something that you find out you didn't predict was going to be a problem, and now you print a solution to it. That's just amazing to me, to think about the opportunities that can exist in our future. But the idea of how can we adapt this to make corporations or our economic systems more efficient, that's not trivial. That's not to be dismissed. That's very important. But how do we use this to improve the quality of life for those that we coexist with on this planet has to be paramount. How are we going to use this to make the quality of life for the most people possible better, so that this doesn't just improve the ability of those who own the means of production, but the people that are benefited from the production itself. So this is the thing that I want us to talk about, as well as how does it actually work, which is, I think, as Adam pointed out, it's off the radar for most of the general public, but once we talk about the possibilities, I think it's then the general public gets there. Oh, that's interesting. How would it apply to me in my life? Can I, instead of I put bread in my toaster, can I just print toast? These are the types of things that become fascinating. And the idea is can I print food? The question, the answer may be no, but you start to think about possibilities, and the possibilities are beyond my limited imagination. And what we can do in the future, the potential in the future, but how does it help people? That's what I want us to focus on when we talk about these, as well as how do we actually do it and what are our capabilities today versus tomorrow. Thanks, Sharif. Wonderful topic.
Thank you, Mr. Dan.
Yeah, that is very good points there, James. I just think a lot of opportunity exists in people sharing these devices. We at the Thousand Oaks Library here in California, they have a small 3D printer, and you can actually send them a file and pay for the cost of the filament and get back a finished part. I printed out a little plastic call sign for a hat, and that way, and I think they didn't even charge me. It was just like a little nameplate. But it's a great trend for libraries to do this. I think that it could be expanded to all kinds of useful tools and resources. If your library isn't offering, remote 3D printing, call up your city government or your librarian and say, "Hey, there's other libraries that are doing this. Why are we behind the curve?" So I could see this being done with the really large house printing 3D printers, because we've got a terrible shelter deficit right now, and it's very easy to just get this circular arm that goes around, and you can even make these where they utilize the soil on site. They actually process the soil. And then just add some lime, perhaps, and other components. So we're just at the cusp of all the opportunities that are presented. And remember, the character for crisis in the Chinese language is the same character as opportunity. So we need to see more of that opportunity side of crisis, because it's definitely out there. And stay positive, and I'll yield.
Thank you. Professor Rob.
Sure. And I'm glad you brought up the medical side of 3D printing, because one of the most interesting conversations I had was in Spain with a prosthetics manufacturer and a guy that was an ex-athlete, well, actually still an athlete, but an injured, and lost his arm and had his prosthetic 3D printed to replace the arm. That was a huge problem with regard to prosthetics, in that they were built kind of like shoes are built according to sizes. They often were not customized, so everybody that had a prosthetic had an ill-fitting one, and so it was very uncomfortable for them. And if you wanted to play a sport or do something that required a lot of movement, that difference in size from what you needed to what you got kind of made it that they couldn't do those things, certainly not comfortably and not without a lot of avoidable pain. But with the 3D printed prosthetic, because it fits exactly, and even if it doesn't, it can be relatively inexpensively replaced with one that does. Allows them a freedom of movement that they didn't have before. And while it doesn't yet automatically include articulation or the ability to move that prosthetic, that's coming. That's a different technology, but that's coming, and clearly the components for that can still be 3D printed. So what 3D printing does is it allows you to inexpensively do small runs of things. That's really where it is. I've heard Adam say it's not very popular in homes yet. Kind of depends on where you live. It's very popular in schools. In fact, a lot of schools here in the U.S., K through 12, have 3D printers now in their labs, and they're playing with them. And I've been getting 3D printed stuff for some time. If you have gone to Etsy, which here in the United States is a place where artisans sell their wares, quite a few of them now are selling 3D printed objects. Very good for movie props. It used to be, if you wanted to get a really nice movie prop, would set you back thousands of dollars. Now it's hundreds of dollars, and probably will get cheaper. But the neat thing about it is you're getting to the point where you can build pretty much anything you can imagine. Granted, in many cases it's more for looks than for use, but the trend is towards use and away from looks. And even the FAA now has approved 3D printed metal parts for jet engines, and their requirements are relatively strict when it comes to the quality of the goods that they are printing. So the tolerances are good. And as I say, the difficulties now are really trying to do blended materials. We have certainly been able to print more complex objects for a while. HP likes to showcase that they print chains on a regular basis, and the chains are changed. They articulate, and moving objects that also articulate. Once again, a little bit light in terms of putting that into a production as opposed to a prototyping environment. But now we are advancing this technology by leaps and bounds pretty much every year. And the end goal, of course, is to have first large-scale 3D factories where you input a set of plans and materials, and out the back end comes the finished product, and then downsizing it so we each have something like that in our homes. And for certain runs of offerings, we call Amazon, instead of waiting for them to deliver it, we just consume a bunch of materials and the thing comes right out of our 3D printer where we are. We're a couple decades away from that, but that's the eventual goal. The more complex, the more complete. First, more expensive than high volume manufacturing, and eventually competitive to high volume manufacturing. But where it currently resides is in being able to build short run parts very affordably.
Thank you, Professor Edward.
Yeah, very good points all around. A couple of other points I'll make, because I always talk about the importance of entrepreneurs. And if you want to talk about human progress, that is, to me, what has happened in the last 200 and some years with the Industrial Revolution. As Adam Smith pointed out, companies and individuals pursuing their own profit have to do it by producing goods and services that other people want. And so that's why we went to, from a situation where the vast majority of human beings lived in abject poverty to, something that's the reverse, and things are even getting better in emerging economies. I mentioned before that in China 40 years ago, before they transitioned to something like a free market policies, something like 9 out of 10 Chinese were below the abject poverty level, international level. Today, it's only one in 10, and that's incredible. So, and I see 3D printing as just part of that process, where entrepreneurs will come in and use the technology to do really cool things. But I want to mention a couple of other important points. It might well be that we don't all own 3D printers like we right now. We all own, or most of us own, these things. We all tend to own, smartphones. It might well be with the Internet of Things that's emerging. We might have a different mix because right now our model is, well, people like Steve Jobs and Bill Gates were able to mass produce, and computers and personal computers and software. So we now all own those. And 12, 13 years ago, no one had a smartphone. Now 87% of Americans have smartphones. Adult Americans have smartphones. And we tend to think of the same model for 3D printing. But I think it's going to be a different mix, because it's kind of, do I really need a 3D printer in my house to print, for example, clothing? And it might well be no, because just, maybe twice or three times a year I need a new shirt or something like that. So I might as well just go ahead and, contract out, so to speak, to my local, whoever has the 3D printer. So I think you're going to see that kind of a mix, especially with what we call the Internet of Things. By the way, I've heard the same argument made. This is maybe a future show for Sharif here, about most of the time my automobile, which is sitting right outside my window in the driveway, most of the time I'm not using it, not just because of COVID, but just because most of the time I'm not driving. So are we going to reach a time where we basically can get a car here, instead of basically owning a car, I just basically get the ride here very, very quickly? And this is not for any ideological reasons. I'm not against automobiles. I love automobiles, but I'm also very practical. So are we going to see the same trend for 3D printers where, well, I don't have to own one, but if I need something, I can just go to my local, you name it, and do it that way. It's Dan, you were talking about that, where you can sort of send something and get it done that way. So I think we're going to see that kind of a mix, and also with industrial uses of 3D printing. So, and that's where entrepreneurs come in, because they sit around and figure this out. I don't know this kind of stuff. If I did, I'd be rich and have a mansion instead of my humble little dwelling here. Okay. But that's what entrepreneurs are going to do. That's what the Steve Jobs and the Bill Gates and the, Elon Musks and the Jeff Bezos of 3D printing are going to do in the future.
Mm-hmm. Thank you, Mr. Adam. Unmute, please.
Always doing that. Thank you, Sharif. I think maybe I was not so clear regarding the last couple of points I made towards the end of what I said there, so I'll just expand. The last couple of points I said before. I think we will see quite quickly how 3D printers will go from just being used in specialized fields and disciplines so far across, that it will eventually go into people's homes, where even children will use them and know how to use them like it was second nature, like how they do with iPads and computers now. So to save time and save space, and to prevent clutter and items and objects gathering dust, like how Professor David Smith described earlier. Let's say, for example, a family is going on holiday to the beach. They 3D print a few toys and objects for things to do by the seaside, like a sandcastle bucket. They 3D print it, use it, have fun with it, and enjoy using it, come back home after their holidays, and again save space to prevent items gathering dust and to prevent clutter. If not needed again, or not for a while, they can put it in a special bin or compartment where the printer can break it down and reuse and recycle materials for the next couple of things that this family will print and use. And then the next time they go to the seaside, they could just 3D print another sandcastle bucket. So this will.
That's what I'm doing tomorrow with my kids. So I wish I had 3D printers.
Yeah, it's I was just thinking, like, like what you said earlier, this will save a lot of things. Littering, fly tipping will save expenses. It will save space and clutter. And remember, clutter can have a rather negative effect on mental health and physical health. Hoarders and people with OCD spring to mind immediately to me. Their mental health drives them to hoard, which just adds to their anxiety and mental health problems as they spiral downwards. And again, with physical health, people are at risk of pests and dust, poor hygiene, or non-existent hygiene. So maybe 3D printing offers a potential solution to people suffering from obsessive compulsive disorders. If an object is 3D printed, there might be far less of a sentimental and emotional attachment to the object, thus soothing OCD and hoarding impulses. And if the materials used in 3D printing, or home 3D printing anyway, were engineered to have a kind of obsolescence engineered in, where the sandcastle bucket, for example, again starts to become unusable after a certain time, then people will want to recycle them back into 3D printing again, and it could help solve problems from there being too much stuff lying around not being used, as well as a strategy to help people not fall into spirals of obsessive behaviors that could negatively affect quality of life and hygiene. And these situations and these conditions cause ripple effects that impact others in people's lives, like family members, friends, neighbors, and so on. So it would protect them as well. Thank you, Shane.
Thank you. Thank you. I directly want to go for the concluding remarks for today. And after your concluding remarks, I just want to take maximum 3 minutes for declarations, our organization, team members, and everyone. And I want to give special thanks those who support World Talent Economy Forum regularly with their open dialogue. But this is the high time that we want to move with the next level, that we want to develop innovation labs with different with the partnership of different universities and the developing nations. And this year we want to target only 1,000 students. We do not want to spread too much. That's why we will declare 40 members committee. And most important thing is that already different countries, they already give us the student database, youth people database. It's about 100,000 people we have. From 100,000 people, we only select 1,000. So 99% we have to deduct. So we will go for a screening process, and I'm sure next level journey will be very much interesting. And if we get all of your support, I'm sure we can change at least the developing nations or the other part of the world. And this world will be very interesting journey for all of us. So what will be the concluding remarks for Professor David Smith?
Sharif, once again, I always love these, and this has been a great dialogue in the different elements. One of the points I would like to echo back, though, is that there was comments made about should we have one of these at home by Edwards and stuff like that. I've used a 3D printer recently to fix one of my old audio mixers. I used my phone and a program to capture a 3D image of it. I put that into a CAD program. I went to, in Austin, one of our maker studios where they have 3D printers, they have drill presses, they have lathes and all that stuff. But I used a 3D printer there. And within 45 minutes, I had the part manufactured to go back home and fix my audio mixer with that. That simple. So it is coming to a place where an average person can use tools that are readily available, go to a center like one of these maker centers, use a shared facility there, and use it very rapidly. That makes it very easy for startups, for entrepreneurs, for researchers to go and use facilities in a way using 3D printing processes to advance science, manufacturing products, companies, even faster than we could in the past. I remember it used to take days to prototype a mask for a semiconductor. I can now do that in seconds with modeling on a supercomputer, and I can very rapidly produce a test mask that would have taken a long time in the past. And I can iterate more. 3D manufacturing lets us do that. It helps us accelerate, it is. And by 3D printing being portable in many instances, it brings it to any country in the world. And it brings it closer to materials in many instances too. So it's one of the future technologies that's there. Companies and countries should spend time understanding it and beginning to experiment and try it and advance it. But it is a technology that levels the playing field for many.
Thank you. Mr. Jamsid.
Yes, I think David's last comment is what I want to focus on. Leveling the playing field, because we get caught up. I get caught up, anyways, in the exciting possibilities, and I get carried away. And I always have to stop myself and ask, why are we doing this? Is it to make money, to make someone rich? Then I'm not that interested. Is it to level the playing field? Then I'm very interested. So I think that some of the things that we have to wonder about, we have enough plastic already. We have too much plastic. Now everybody can make plastic. It's like, why are we doing that? And there's real good reasons, and there's real good possibilities, but look at the consequences of the amount of plastic we have already and how it's affecting the environment. What if we increase that exponentially? Everybody can create plastic, more plastic, more plastic, more plastic. That's not biodegradable. That's a problem. So we have to think these things through in a larger systems like a approach. So why are we doing this? And what we're doing, let's look at the consequences as well as the benefits, because we often get caught up, I do anyways, in the benefits. And we have to think also about the downsides of some of these things. We got enough plastic. Why would we produce more? And it's not just to be more efficient and more effective. It's got to be more efficient and more effective at doing what? Making the quality of life better. And also, we have to ask ourselves, well, who's going to control this? Because I'm all for entrepreneurs and entrepreneurial spirit. I'm all for it. But, what we have seen, our history has taught us, is that by patents or by monopolies, somebody gets control of it. And then who has access to it once somebody has control over it? And so we want it to be a democratic process. We wanted it to make it more people have access to more things. But is that really the future we're talking about? Or is somebody going to patent the process, control the process, monopolize the process, which ends up stifling competition? So let's not make the same mistake that we have made so many times in the past with this new technology. So that's one of the things that I would like to end on. And I just think that we really want to think hard about why we're using this. Because technology is neutral. It's not good or bad, but how we use it can be for good or for bad. And so keep our eye on the ball. We want to use this technology appropriately as a boon to society and not to make someone rich. Thanks, Sharif.
Thank you. Thank you. Mr. Dan.
Boy, I wish Ben Franklin were alive today, because he would be all over this stuff. I mean, he was like the prototypical American open source transhumanist guy. Yes, there's Edwards on top of him as one of our heroes. And I think one of the beautiful things about the American project, the American experiment, is it's really an experiment in open source opportunity in peer-to-peer voluntary creation of innovation and new ways to interact that people are just surprised. Oh, I didn't know we could not have the divine right of kings. Oh, I didn't know we could not have feudalism. I didn't know we could all manufacture our own goods faster and cheaper than we could buy them from distant questionable suppliers. So recently Andrew Yang was the presidential candidate in the last election cycle, and he was mostly running on the idea of what he called the automation dividend. It was a plan for universal basic income that he says we never really received the benefits from all these jobs that are being automated away. Basically, any job that's being done that's intelligence dependent, it's inevitably going to be done faster, cheaper, quicker, better, outsourced to some kind of automation process. And you're going to have a lot of displaced people. The opportunity side is you now have people that can be more creative, more fulfilled, less robotic. They can follow their creative bliss more. But again, people don't always grasp the opportunities that are around them. But I think America is not about equality of outcome, but it's about equality of opportunity. So again, I think this notion of a UBO, universal basic opportunity, should work in harmony with any notion of a UBI. And I think the Transhumanist Party platform is very well adapted to that, and I would encourage people to check it out. It's the kind of rational discourse that can bring the peaceful and just society that we're all hopefully striving for. So thanks again for the
Thank you.
the great opportunity today.
Thank you. Thank you. Thank you. Professor Rob.
So I just want to clear up some things. 3D printers don't manufacture plastic. They use plastic material that is manufactured by others that comes in a variety of forms. In line with the creation of 3D printers is also the creation of bioplastics. These are plastics that are designed to degrade much more rapidly over time. And when you're developing one process, sometimes you're able to use a different approach to how you're doing things. And fortunately, the approach, at least in the United States industry now, has put a lot of emphasis on biodegradable offerings and being able to at least reuse the plastics, if not allow them to degrade naturally over time. So that's all happening in pace, but it does require focus. Often the biodegradable parts are more expensive, and if consumers aren't willing to spend money for them, then the industry probably isn't going to be able to sustain that direction. But right now, that's the direction the industry wants. It just a matter of whether the market will help sustain them. Where 3D printing is right now, it's not taking any jobs away per se. It's allowing people to do things that otherwise would be unaffordable, like short-run parts. And it is opening up an entire market of artisans. I mentioned what I ordered with 3D printing. This came in just the other day. I had 3D printed. It's a Rocket Man headpiece, but it looks just exactly like it would if it had been made out of bronze and welded, and this was 3D printed. And so you've got a whole group of folks. I run into them on Etsy that are building these things that you otherwise couldn't afford to have built. That are just kind of fun and are artsy, but also could be used if you were using them to mock up a project, or just explore what you could build with your imagination. It's allowing people with some decent computer skills to advance those skills and enter a market as an independent, and not necessarily have to hold a job with a large company. And since I kind of work for myself, I'm a big believer in that approach. Some of it really work well in large companies, some don't. And the future of 3D printing, at least near term, is probably going to be more along the lines of enabling small businesses to do things which could only be done by larger plants in the past, and do them with enough scale to support an income and have fun. So done in that way, 3D printing can be beneficial. The other thing that we've talked a bit about is how 3D printing is changing surgery and changing the ability to create prosthetics. That is really a greater good thing, because the building prosthetics is very expensive, and as I mentioned before, often the result is ill-fitting, and the 3D printed products tend to fit better and be far cheaper than the products that were traditionally built. And the end result is you've got a lot of people that now can get nice fitting, otherwise high quality prosthetics that would not have been eligible for or been able to afford them in the past. Particularly beneficial for those that hurt in military engagements, which were often the ones that suffered the most from that lack of funding for highly fitted prosthetics. And then finally, we're still at the very beginning of this. The 3D printing and the follow-on 4D printing, which is I'm not sure why they came up with 4D, because the fourth D isn't a dimension, but really talks about being able to print objects that are operational after they're printed. It's changing what we can do, and it's allowing us to do customization at scale. As we watch the automotive industry shift from building cars and then selling them off lots, a lot of times those cars remain unsold and eventually make it into landfills and crushers. moving to build to order, so that they're only really building what it is somebody wants to buy. That in and of itself will reduce waste somewhat, and it will allow things in the future, like car companies that something like Tesla has explored in the past, being able to upgrade cars over time rather than replace them. Also keeping, if we ever make it down that particular path, an awful lot of stuff out of landfills that's going there right now. So it's got the potential to make change. The one final thing, I think I mentioned the industry with regard to plastics and biodegradable products is a plastic recovery. The industry is looking really hard at plastic recovery, both recovering the unused plastics that end up after 3D printing, which in itself is much less wasteful. You typically use the plastic you are going to actually use in the part, as opposed to some types of plastics manufacturing where there's a lot of leftover waste that comes after a result of milling and cutting off the support structure. 3D printing tends to produce less waste to begin with, but to keep the cost down, it's very beneficial to be able to reuse the plastic, and certainly be able to reuse the unused material. And a lot of the machines right now, HP being an example, they reuse, I think, so 80% of the manufactured plastics get reused as they print through. And they're looking to get to 100% in full reuse over the next 10 years. And so the industry gets why this needs to really help the environment and not hurt it. And for right now, it seems to be more additive in terms of jobs than subtractive, because you're able to do things we weren't really able to do affordably before. And it's enabling a whole new group of artisans that otherwise couldn't exist at scale, and opening up that concept to a lot of people that otherwise it would be unavailable to. So for the most part now, it's beneficial, but like any tool, it can be used for good or ill, and will require a focus on making sure it stays beneficial in order to make sure that it does.
Thank you. Professor Edward.
Yeah, a couple of quick things. By the way, the book I mentioned earlier is actually called The Far Shore by D'Amato. So if you're interested in a good science fiction story that has 3D printing in it, then take a look at that one. But a couple of points. First of all, I want to point out that it's the pursuit of profit that has given us the fact that everybody in the United States now pretty much can own a personal computer. It was the investments made in those technologies that have allowed, for example, everyone, 87% of adults now have smartphones, whereas in 2007, no one did in the United States because they were just being introduced. It's profits that has allowed Jeff Bezos and Elon Musk to take that money and put it into private rockets that are becoming much more efficient than some of the ones that NASA has produced. And I've worked on space policy with NASA people for many, many decades. So I just want to point out that I think Yang is incorrect when he says, well, where is the dividend from all of this? The dividend is on our desktops and our laptops and in our pockets. That's where the dividend is. But I want to focus again on the 3D printing issue. Again, where 3D printing is a tool, like any other tool. And we're seeing, and it's entrepreneurs, and it's the kind of discussion we're having right here, that we're going to see where exactly it fits in. And I agree with the points that Rob has made and some of the others, where it's going to fit in. But it's ultimately going to be business folks, entrepreneurs, and so forth, who look at the system and say, I think we can use it here or some other place, etc. I'm very positive about the use of 3D printing for medical issues. By the way, this might be a future show. There's a very good discussion document that Samsung put out on 6G and how 6G is going to enable even more the so-called Internet of Things. So when I think of, say, 3D printing or some of the other discussions we have, I think of it as integrated into what's coming, for example, with, I think it's with 6G. So I think we have to think of this integrated way. And again, entrepreneurs, and especially young people in Asia, Pacific area, really are in a very exciting time, because they can take all of the shows that you have done, Sharif. You can look at all of these issues, and then you can try to put them together so you have this synergistic thinking about not only how to use 3D printing, but how to use nanotechnology and how to use all the other things that we've discussed on these shows. So again, other great show, and looking forward to some future ones.
Thank you. Mr. Adam.
Thank you, Sharif. I was also thinking about the Internet of Things again as well, like what Mr. Edward Hudgens said. And 3D printing will naturally play a crucial part in that future scenario. So we need to protect ourselves from falling into punitive and oppressive modes of existence where Billy can't 3D print a sandcastle mold bucket because his dad said something rather positive and nice about an unpopular public figure that was a scapegoat for mainstream society decades ago. So again, it's looping back
Empower.
to the what's that?
I said, yes, empower the individual.
Yeah, certainly. I mean, yeah, especially now. So again, it's looping back to the topic of the digital social credit system again, and we need to stop our leaders from falling to temptation to wield this ultimate form of power and control. And what Mr. James Eade said was saying just then made me ask myself, or try to imagine or ask myself, will 3D printers extend to dispensing liquids after 3D printing a receptacle, or at the same time as 3D printing a receptacle? Or about gases, how much of a limit will authorities enforce to place restrictions on what people can print at home and cannot print at home to prevent bombs and weapons being made? And will it be possible to get a license? When will they expire? What could warrant the license being revoked? Will there be committees and panels? Will there be different levels so someone can print something just once a year under something that can only be printed once a decade, which is then under something which can only be printed by a multinational corporation once every 2 decades, and so on? And I like what Mr. Professor Rob Enderley said just then. I imagined a new age of artisans and guilds and craftsmen, so people will still be able to do something in the age of automation, which we discussed recently, of course. So that could offset displacement and despondency. It could be a door to a new age of enlightenment or a new renaissance. And depending on who you ask, the widespread employment of people in offices working 9-to-5 jobs comprised of people who would rather be doing something else and being shouted at by bosses and having to do overtime, that has probably had more of a diminishing effect on creativity than the future automation ever could. And that future automation could open new opportunities for new waves of creativity explosions, where 3D print would be one of the developments at the heart of such an artisan renaissance with new generations of polymaths again. Thank you, Sharif.
Thank you for excellent discussions. I just need to finish one thing, because our 40 members committee finally we want to declare, even example, any of you want to share it with the media, you can share, or with your community you can, but your all of our members certifications we will forward soon. We are working on it, so we are just declaring finally the 40 members committee. So our major objective, like in between 2022, we want to train only 1,000 students. Already we get a 100,000 student database from Asia Pacific, even from India. We are getting a different kind of knowledge-based collaboration from university, NGO, and governments. On the other hand, from Italy, Japan, but for 1 year, just we want to focus on 1,000 students. From 100,000 students, we will collect only 1,000 students. So our board of advisors, our ambassadors, and our team, basically, they will work on this innovation lab. And we want to develop a knowledge-based economy. So that's why we want to focus more on startup. We want to produce next decade's Elon Musk or this kind of innovative people from our ecosystem. So our board of advisors and our members are Professor Edward, Mr. David Smith, Mr. David Wood, Professor Rob, Professor Donald, Professor Talib, Mr. Tom Rose, Mr. Ganidi, David Schumacher, Iftekhar Pathan, Kimberly Homestoner, Professor Fred Philip, Paula Natasha, Pauls, Professor Adrian, Dr. K. Ali, Dr. Soha Akiki, Mr. Daniel Julkifli Ahmed, Dr. Tausif Malik, Ramlan Osman, Jennifer, David Wood, Durga Dash, Sohel Rana, Adam James, James Eid, Humaira Tanzila, Alex Londos, Oshnakachi Akuma Kalu, Richard, Arifur Rahman, Mr. Kumar, Mark Lee, Kelvin Ogba, Nicholas, Alex, Rahel Javed, and I will serve all of our team members. So this is the 40 members committees. We are just declaring this 40 members. So these 40 members, like we will sit together. Definitely, we will find out the strategy how we can develop a better innovation. But I want to give you good news. Already, we get campus from the local ecosystem. One from Malaysia, another from Paris. We get a very strong student database from the local students, and the student will get scholarships as well as 100% student if they want to move with this startup ecosystem. The local ecosystem will help them. On the other hand, if they want to go for the job in the local ecosystem, they can go for that. So this is the way we are getting some sort of commitment from the government as well as from the corporations. But we need more of the support. We need to do more brainstorming, how we can work together, how we can support each other, because you people are very, very important. And two things we always focus: number one, excellency, and number two, transparency. So those who join in our team, I know all of you are highly successful in your professions, so your contribution will be very, very helpful for us. And another things I just want to declare in front of the discussions, because all of our speakers, without any payments, without anything, they join in the regular discussions. This is because they have planned to contribute. They love to contribute for the global communities. Basically, only the good relationships we provide, but we want to go to the next level with our World Talent Economy Forum. So that's why we are working hard. We believe in open dialogue, but now we have to do some field work. I can give you the guarantee, let's say the Italian governments, Japan government, Malaysian government, they confirm me they want to develop startup ecosystem, like startup village, so we can help them. So on the other hand, Indian, they have some big NGOs, they have 1 million students. In Malaysia, they have 100,000 students. But first year, because of develop our competencies and our good relationship and good reputation is always important, we only select 1,000 students, only 1,000 students. So I know all of you are very busy with your work, but when you're free, if you have any concept paper, you just share with us. If you have any idea, you can share with us how we can develop a better innovation lab for the youth communities. This is our objectives. So thank you. But I'm sure this previously we successfully arranged this kind of academy. I can share one of our academy in 2013. We successfully arranged it, and we get all of our support and everything from local corporations. So hopefully this time we can arrange necessary support from local corporations and governments, and we have good reputations for arranging this kind of academy. And most important thing is that the youth community, they have full trust on us that we can build something. So hopefully with your contribution, not only this open dialogue, we can develop a better world, and you can produce maybe the next decades Elon Musk or Mark Zuckerberg or more innovative person. So this is the commitment I provide to the local ecosystem. And we have our excellent international team, not only from Asia, from Europe, from Africa, from North America, and all of them are best in their place. So we believe in quality. I'm sure all of your contribution, we can develop a better world, and definitely it will be like a business organizations. So we are looking for like good things, how we can develop better business model. So all of your experience and everything we will apply, and I'm sure we can do it. And trust me, this way I'm sure in between 5 years we can produce 1 million students, and this 1 million students and 1 million youth community, they will change their community. And this is the way we can work together. So I'm open for collaboration, I'm open for learning, I'm open for discussion. So I think that we can do a brainstorming session soon. Thank you, Professor David Smith, Mr. James Ead, Mr. Dan, Professor Rob. Actually, he comes from the day one. If you see our YouTube channel, he from day one. So Professor Edwards, Mr. Adams, for your continuous support for World Talent Economy Forum, and trust me, you win our heart. We have more than it was so difficult to organize such a team. From 300 people, we just bring 40 people in a one team. But you can believe on our visions. We will make it. We will make it successful. Yes. Anyone want to share something?
Agreed.
Okay.
Yes, this is a global perspective of what we're doing here. It's not about one person, one country. This is a worldwide movement.
Yeah.
We believe in teamwork. We believe in teamwork. Individually, I'm nothing. If we work as a team, definitely we work as a family, maybe we can build something big. And I believe we can do it. And from my side, I will do my best. If we have to convince corporations, we have to convince the government, we have to convince the NGOs, local youth community, local peoples, 100% I will do my best. But I know all of you have a huge networks. So if you have anything, we are open for that. Yes. Okay. Thank you. Thank you, everyone.
Ciao.
Thank you. Live long and prosper.
Bye-bye. Bye. 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 Take care. Bye.